In this video, I'll be going over the concept of binomial expansion and how to write our answers as a polynomial. So we've actually done binomial expansion. Bi meaning two terms. So like for example, if we had, let's say, x plus 3 to the second power. Well, we have done this in the past where this is the same as x plus 3 times itself, x plus 3. Then we could do FOIL or you could do box method. And then the final answer would be x squared plus 6x plus 9. So this is expanding this original binomial here that was raised to the second power. But what if now you have a higher exponent than 2? What if you had x plus 3 but to the fourth power? So instead of having to go through and multiply over and over, we're going to use Pascal's triangle. So Pascal's triangle here is just the array of the numbers here as shown below, where the triangle, every row, we start with 1. Notice how we start and end with the number 1. And each row is, what we're doing here to create is we are adding from the previous row. So like for example, here in Pascal's triangle, if you notice, we have 1, right? That's our first row. That's our, what we're going to call our 0 row. That's the starting from the very beginning. Then we go to our first row here, which is again just 1 and 1, because we have to start and end with our row of with the number 1. So then the second row, now we're adding another term to it. So we went from 1 term to 2 terms, now to 3 terms. Notice how here, when you add these two together, 1 plus 1 is 2. So the second row here considered is 1, 2, 1. So then the third row here, what we're going to call row 3. We're going to take these two previous numbers, right? We're going to always start and end with 1 and then add the numbers between here to create. So 1 plus 2 is 3. And 2 plus 1 is 3. So this is the next row in Pascal's triangle. So now the fourth row. The fourth row, again, you always start and end with 1. Then here we always take between and add the two numbers from the previous row. So 1 plus 3 here is 4. Then 3 plus 3 here is 6. 3 plus 1 is 4. And then last is 1. And then we're going to stop here, but at the fifth row. Now you can keep going with Pascal's triangle because it goes on and on as this pattern. You always start and end with 1. And then remember here, right? We're going to take the previous, we're going to add those two to create that fifth, what we're going to consider our fifth row here, or row 5. So 1 plus 4 is 5, 4 plus 6 is 10, 6 plus 4 is 10, and 4 plus 1 here is 5. And we could continue. So we would have 1, then 6, then 15, then 20, then you see, so, but we're going to stop here with Pascal's triangle. Now, these numbers here in red are actually what's going to represent and what we get from the exponent. So when we have our binomial raised to a power, these rows here, these numbers are where we get the we get that from the exponent, and that's how we know which row we're going to use. And each row, so these numbers here that we created represent the coefficients. So these numbers here actually represent part of our answer. They are going to be the coefficients. And again, like what I said before, right? The exponent is represented by each row. So like again here, I've got 0, 1, 2, 3, 4, and row 5 here. We're going to stop at row 5. We are going to expand x plus 2 here, but to the fourth power. So that means we are going to use the row represented by that exponent of 4. So these are the coefficients here that we are going to use. So we're going to first do this organization here to come up with our final answer, the polynomial. So we're going to list our coefficients first. So the 1, 4, 6, 4, and 1. Then we are now going to list the terms that are in the binomial. So notice how we have x here. So I have x, but remember, right? Everything is being raised almost as if it's like to the fourth power. So first off, what I'm going to do is I'm going to bring down my x. Then this is starting off as x to the fourth. Then I'm going to count down. So I'm going to go 4, 3, 2, 1, 0. Then the last row is the second term of the binomial, which here is positive 2. So positive 2. However, we need to make sure that our exponents always add to 4. So I'm not going to put 4 here because 4 plus 4 is 8. That means we need to go backwards. I'm going to now start 4 down here. 0 plus 4 is 4. So 4, 3, 2, 1, 0. So notice how the exponents still in each row add up to 4. And now we're going to simplify. So this is 1 times x to the fourth times 2 to the 0. So here that is 1 times x to the fourth times, well, 2 to the 0 power is 1. So that gives you just x to the fourth, because that's just being multiplied by 1. Then next, I've got 4 times x to the third times 2 to the first. So that's 4 times x to the third times, well, 2 to the first power is 2. So now notice we do have 4 times 2, which is 8, x to the third. Then the next row, I've got 6 times x squared times 2 squared. So 6 times x squared times 2 squared, which is 4. Notice again, we have 6 times 4, which is 24, x squared. Then the next row, I've got 4 times x to the first times 2 to the third. So 4 times, well, that's just x if you think about it, right? X to the first power times 2 to the third power, which is 8. Then here we have 4 times 8, which is 32. So 32x. Then our last, we have 1 times x to the 0 times 2 to the fourth. So that's 1 times, remember, anything to the 0 power is 1 times 2 to the fourth, which is 16. So really, we're just ending here with 16. This is the terms. These are the terms of our final polynomial answer. So x plus 2 to the fourth power is x to the fourth plus 8x cubed plus 24x squared plus 32x plus 16. So this says you try, but again, I'll still talk you through this. Make sure that you are identifying kind of like as I'm pausing here through the video. So let's go ahead and again label. So this is our 0 row, right? This is where we're just starting from the beginning. And 1, 2, 3, 4, and 5. Go ahead and identify, so which row are we going to use as our coefficients? The third row, good. Why? Because this is being raised to the third power, our binomial. So let's use those coefficients. So 1, 3, 3, 1. Now list the term. So the term here, we start off with x. So I'm going to list my x, but remember, right, they're all being raised to that third power here. So we're going to start at the third power and count down. 3, 2, 1, 0. So then the second term of the binomial is positive 5. So go ahead and list, and then how are we now going to set up the exponents? Bottom up, good. So 3, 2, 1, 0. And notice how the exponents all add to 3. So now let's simplify. Multiplying 1 times x to the third times anything to the 0 power is 1, giving you plus x to the third. This is 3 times x squared times 5 to the first. So 3 times x squared times 5 to the first, which is 5. Then notice you have 3 times 5, which is 15. So 15x squared. So go ahead and pause the video and do these last two rows, and let's make sure you get the last two terms. And here we go. So 3 times x to the first times 5 squared. So that's 3 times x to the first, which is just x, times 5 squared, which is 25. Then notice here I've got 3 times 25, which is 75. So 75x. Then the last. So here you've got, you've got 1 times anything to the 0 power is 1 times 5 to the third power, which is 125. So really you're just ending with, and you should have gotten 125. So your final polynomial answer is x to the third plus 15x squared plus 75x plus 125. So same thing now with example 2. We're going to list them out. So let me identify here. So 0, then 1, 2, 3, 4, and 5. So which row are we going to use? The fifth row. So this is 1, 5, 10, 10, 5, and 1. Then let's continue with our terms. So the first term is x. So x to the fifth power. So that's where we're going to start. X to the fourth, x to the third, x squared, x to the first, and x to the 0. Then the next term, notice how because of the -3, I'm going to put this in parentheses, all right? So -3 all the way down. And then how do we set up our exponent? Bottom up. So 5, 4, 3, 2, 1, and 0. Now let's simplify. Here we go. So we've got 1 times x to the fifth times -3 to the 0 power. Well, that's just 1 times x to the fifth. And remember, anything to the 0 power is 1. So the first term, x to the fifth. Then here I've got 5 times x to the fourth times -3 to the first. So that's 5 times x to the fourth times -3, which here 5 times -3, -15 times x to the fourth. Then next up we have 10 times x cubed times -3 to the second power. So I've got 10 times x to the third times -3 squared is +9. Then here we've got 10 times 9, which is 90x cubed. Then next up, 10 times x squared times -3 to the third power. So 10 times x squared. Now, -3 to the third power, make sure you get -27. Then here we've got 10 times -27, -270x squared. Then let's go to the next row. Here I've got 5 times x to the first, then times -3 to the fourth power. So I've got 5 times x, then you should get +81. Then here, 81 times 5 is 405x. Last row here we go. So you've got 1 times, anything to the 0 power is 1, then times. Notice how what's happening to the signs with the negative. I started with a positive, then I went negative, positive, negative, positive. So what's this going to be? Negative. And then 3 to the fifth power, you should get 243. So -243. So then really that last term is -243. So our final answer is x to the fifth minus 15x to the fourth plus 90x cubed minus 270x squared plus 405x minus 243. Notice, so here it's all the same, except because of having minus in our binomial, that negative, we ended up alternating signs. So we have a positive, negative, positive, negative, positive, lasting, and last a negative. So go ahead now and pause the video here. Try this one on your own, and then let's see what you get. Now let's go over it. So notice how we have x minus 7 being raised to the third, being raised to the third power here, which means the row you should have used is 1, 3, 3, 1 for your coefficients. So 1, 3, 3, 1. Then listing your terms. So I have x first, and then x to the third, 2, 1, 0. So then the next is negative 7. So negative 7, but now bottom up. So 3, 2, 1, and 0. So now as you simplify for the first row, you should have gotten 1 times x to the third times 1, because anything to the 0 power here, I just realized I don't have my parentheses. Sorry about that. Anything to the 0 power here is 1, making that x to the third. And 3 times x squared, but now times negative 7, because negative 7 to the first power is negative 7. You get negative 21 x squared. Then next, you have 3 times x times positive 49. Negative times a negative, positive 49. So now here, 49 times 3, you should have gotten, sorry about that, guys. You should have gotten 147x. And then the last. So here you have 1 times anything to the 0 power is 1. And then notice how we're going back flip-flopping, right? So I know I need negative 100. Oh, wait, sorry about that. Not 100. You should have negative 343, which here is still negative 343 because you're just multiplying by 1. So the final answer you should have gotten is x cubed minus 21x squared plus 147x minus 343. So then here, what if we had now exponents inside? Same thing, we're going to use the exponent on the outside, so we're focusing on here, this row of coefficients from Pascal's triangle. So I've got 1, 3, 3, 1. Then list the terms. Now notice how this is 2x squared. So 2x squared, because there's multiple, put everything in parentheses to keep everything together. Very important here now. It's not just a negative. And 3, 2, 1, 0. So then the next term is negative y cubed. So negative y cubed. That is the next term. And again, bottom up. 3, 2, 1, and 0. So now you need to focus on, this is going back to algebra 1. So I'll take my time with this one. We're still multiplying. So here I've got 1 times, but that is 2 to the third power. 2 to the third power is 8. You have to remember here, guys, that is a power to a power. So if I have x squared raised to the third power, our rule is with exponents, a power to a power, we're now going to multiply. So that is x to the 6th power, not 5th. So a power to a power, multiply. And how I like to say it, pow, pow, multiply now. Yes, I just said that. Then anything here to the 0 power is 1, making our first term 8x to the 6th power. Let's go to the next row. Here we go. So I've got 3 times, that's 2 to the 2nd power, which is 4. The power to a power, pow, pow, multiply now. So now you've got x to the 4th power times negative y cubed raised to the 1st power. So again, power to a power, pow, pow, multiply now. That's negative y to the third power, which here, notice how you have 3 times 4, but don't forget that negative. So that's why it's a negative 12, not just 12. Then x to the fourth, y cubed. Then the next row. Here I've got 3 times 2 to the first power, which is 2. But power to a power, pow, pow, multiply now. So now that's x squared. Then here you've got 3 to the second power. Again, pow, pow, multiply now. So now that's going to give you, however, because this negative is also being raised to the second power, remember, flip it. So now this is a positive y to the 6. Then 3 times 2, you get 6. So 6x squared, y to the 6. Then the last row. Here I've got 1 times anything to the 0 power is 1. Then again, power to a power, multiply. But now notice we need a negative. So negative y to the 9th power, which here you end up with just negative y to the 9th. So our final answer here, polynomial, is 8x to the 6th minus 12x to the 4th, y cubed, plus 6x squared times y to the 6th minus y to the 9th. So now pause the video and try this one on your own. Now let's see how you did here. So using the exponent on the out, we're again using 1, 3, 3, 1 as our coefficient. So 1, 3, 3, and 1. Then list out the terms. So that is a positive 3y. So 3y, keep it together. So 3y. And then let's include now our exponent. So 3, 2, 1, 0. The next term was a negative z to the fourth. So negative z to the fourth. Keep it all together, right, in parentheses. Then the exponent bottom up. So 3, 2, 1, and 0. Here we go. Multiplying together, that is just 1 times. Here we go. 3 to the third power is 27. Then y to the third power is just y to the third power. Then anything to the 0 power is 1. So the first term is 27, y to the third. Then next up, I've got 3 times, here we go, 3 to the second power is 9, but y is also being raised to that second power, so y squared, times negative z, but 4 to the first power, pow, pow, multiply now, so that is a negative z to the fourth power, making this answer not positive, but negative 27 y squared times z to the fourth from 3 times 9. Then the next row. Here I've got 3 times 3 to the first power, which is again just 3, and y to that first power, which is just y. Then times, notice how, right, we're flip-flopping, so positive, negative, so a positive. 4 to the second power, power to a power, multiply. So that is z to the 8th power, making our final answer 9y times z to the 8th. Then our last row here, 1 times. So here, anything to the 0 power is 1. Notice how positive, negative, positive, so now we're back to a negative. Then power to a power, multiply. So that is z to the 12th, making our final answer negative z to the 12th. So here we've got final answer, 27y cubed minus 27 y squared times z to the fourth plus 9y z to the 8th minus z to the 12th.